Developing Algorithms with Arrays, Part 5. In this video, we will demonstrate how to determine if an array is sorted. Consider the following program where we declare this array of integers. Suppose I want to determine if this array is sorted from least to greatest. The first step will be to declare a Boolean variable named isSorted that's going to store our final result. If the array is indeed sorted, it'll be true at the end of the program. If it is not sorted, it'll be false at the end of the program. For now, we're going to assume true. We're going to assume true until proven otherwise. The next step is to set up a for loop. Our goal is to look at each value in the array, so we're going to start by initializing I to 0. Then for the stopping point, I'm going to put a question mark for now. The reason I'm doing that is because although typically when we're looking at each value in the array, our stopping point is typically at nums.length, the length of the array, for this situation, it's going to be a little different, but I'm going to wait till towards the end of the video to explain why. So for now, we're simply going to leave a question mark for the stopping point. Then for the increment, we're going to increment I by 1 every single time. Then, inside our for loop, we're going to test to see if our array is increasing. How are we going to do that? First with an if statement. Then for the condition, not only am I going to look at the value at index I, but I also want to look at the value after it. I want to look at the value at index I plus 1. The reason I'm doing that is because I'm going to compute the difference between the two values. I'm going to subtract the value at index I from the value at index I plus 1. And if the array is indeed sorted from least to greatest, I should get a number that's greater than 0 because the number at index I plus 1 should be larger. Thus, if I get a result that's less than or equal to 0, that means our array is not sorted, which in that case will set the isSorted variable equal to false. And once again, it takes only one pair of consecutive values for this to be true to ruin it for the entire array. So once this happens once, we're going to go ahead and break from the for loop. We don't need to check any more pairs of values because once we find one pair where the pair is not increasing, that means the entire array is not increasing. That's all we would need to do for our if statement, and that's all we would need to do for our for loop. After that, all that's left to do is to print out the final value of our Boolean variable. So let's demonstrate how this for loop would operate on the array. We start by initializing I to 0, but as stated before, when I is 0, we're not just looking at the value at index 0, we're also looking at the value at index 0 plus 1, which is index 1. And then we're going to subtract. We're going to subtract 7 minus 4. When we do that, do we get a number less than or equal to 0? No, we do not. So we do nothing. We're good for now. Next, I equals 1. And when I is equal to 1, we're also going to be looking at index I plus 1, which is 2. What's 12 minus 7? Do we get a number less than or equal to 0? No, we do not. So we're good for now. We skip the if statement. Next, I equals 2. And 2 plus 1 is 3, so we'll also be looking at index 3. What's 23 minus 12? Do we get a number less than or equal to 0? No, we do not. So we skip the if statement. Next, I is equal to 3. 3 plus 1 is 4, so we're also looking at index 4. What's 27 minus 23? Do we get a number less than or equal to 0? No, we do not, so we once again skip the if statement. Next, I is equal to 4. 4 plus 1 is 5, so we're also looking at the value at index 5. What's 35 minus 27? Do we get a number less than or equal to 0? No, we do not, so we skip the if statement once more. Next, I is equal to 5. And 5 plus 1 is 6, so we're also looking at the number at index 6. Is 39 minus 35 less than or equal to 0? No, it is not, so once again, the condition is false, so we skip the if statement. Next, I is equal to 6. I'm testing this value because, as you know, anytime we iterate through an array, we start at the first value, then test every single value in the array, including the last one. However, the problem with doing that in this situation is that when I is equal to 6, I plus 1 is equal to 7, which is not a valid index. Thus, if we were to execute this program, we would end up getting an array index out of bounds exception. Thus, in this case, testing the last value leads to crashing our program. So, and not only that, but it doesn't make sense to test the last value because there is no number after it. So even from a logical standpoint, it doesn't make sense to test the last value. Where we want to stop is the second to last value. That's the last value that we want to test. Thus, going back to the question mark we put before, instead of putting nums.length, which is what we usually put when we're testing each value in the array, instead of stopping at nums.length, we want to stop at nums.length minus 1. That's our stopping point. Since we're adding 1 to the I value inside our for loop, we need to subtract 1 from the stopping point to put nums.length minus 1. Now that the for loop is complete, all that is left to do is to print out the final value of isSorted. Since the condition in the if statement was never true, it was always false, the isSorted variable never got changed from its initial value. Thus, when we print it out, we get true as our final output.